Wonderful. Welcome to the afternoon of Tech Day 1. Yes, I know it's going to be hard because it's your nap time. I'm Dan Ortega, your host for TrackS Session 13, Accelerate Application Migration and Modernization with Layer 7 Connectivity. I know that's a mouthful, but our folks here are going to be able to explain everything. It's so great to be learning along with you all. And next up, we're going to have Jason Lovelace and Liam Curtin. Don't forget to ask questions in the chat room. Don't be shy. Just put them in there and we will get to them at the very end of the session. And I will just jot them down and we'll be able to hopefully respond to all of them. And without further ado, I'm going to hand it over to Jason. Jason, you're on.
Thanks, Dan. Hey, everybody. My name is Jason Lovelace. I am an outbound product manager with IBM, working in the IBM software networking team. Liam, why don't you go ahead and introduce yourself?
Hey guys, my name is Liam Curtin. I'm a product manager on Hybrid Cloud Mesh. So thanks very much for joining our session today. Look, hopefully we'll teach you something new.
Cool. All right. So we are, this session is actually scheduled for an hour. Liam and I understand the joy of sitting through potentially an hour-long presentation. So we're going to actually try and move a little more aggressively with our timeline. I'm going to walk through some slides conceptually. Liam will be, I'll be kind of throwing it over to Liam for color as we go along. Liam will actually be giving a demo a little bit later. And just a little bit on background. Liam and I do this a lot. We actually present on the topic that we're talking about. My background is actually in application development. Liam's background is infrastructure and networking. And if any of you guys, if anybody on the call works in software development, you understand that there's kind of a yin and a yang, right, to application and networking people working together. And, you know, but that's hopefully you'll see today, you know, as we talk about this topic, is something we're both very passionate about from our respective backgrounds. So with that, I'm going to go ahead and jump in. So we want to talk today about how you can accelerate application migration and modernization initiatives, but more broadly, the whole idea of accelerating application development by fully understanding the applicability of layer 7 technologies to application and networking. And so the way I always want to start and talk about this is we want to talk about the order in which kind of decisions get made in a company, right? So, you know, company goals, the development team's goals, and the networking team's goals in an ideal world should be very closely aligned. But in reality, right, different parts of this equation have different things that they index on. And it doesn't always go super smoothly. So obviously companies are really focused on things like driving revenue, lowering costs, improving user experience, you know, meeting compliance and regulatory challenges. And as a result of those company goals, development teams will develop roadmaps of things that they need to build, whether that is net new build or they need to modernize, deal with tech debt. They need to move things around to run from one place to another to take advantage of capabilities. So, you know, development teams are relatively closely aligned to thinking in terms of business goals because most development teams, whether they're tied to product management or program management, are thinking about how does our roadmap support the company's goals around revenue, costs, you know, employee or customers, compliance. But then the interesting part comes when we start translating development teams' goals into networking teams' goals, because the complexity of what networking teams do is very tied to the physical infrastructure of a company, whereas the development teams are, in theory, somewhat abstracted by that, although they're very much dependent on it. And this leads us to this concept of the incentives dilemma that exists between application teams and networking teams. Application teams view moving quickly as a good thing because it enables them to move as quickly as possible to accomplish whatever the business goals that their roadmap has committed to. But networking teams, however, are actually incented the opposite way, which is networking teams are typically incented to move more slowly and more deliberately because networking teams is where the majority of the risk of an organization sits in terms of ensuring that there's no downtime, that they're not affected by latency or performance issues, that there's no security breaches. So for networking teams, moving slowly and deliberately through whether it's process or the implementation of tooling to drive automation is a critical part of them accomplishing their goals. Whereas application teams are incented to move as quickly as possible. And this creates a real incentives dilemma and a dilemma in terms of how application networking teams work together. And one topic that Liam and I are going to talk about for a second is that the junction of this comes when application teams need to make changes, and those changes are dependent on the physical infrastructure of a company. And as a result, they're dependent effectively on traditional layer 3 networking approaches where applications, especially applications that are not just sitting in one VM, need to have network configuration in order for changes to be made, whether they're building net new or modernizing or migrating. Traditional layer 3 networking is the thing that it constrains how application teams quickly they can move. My experience from an application perspective is that frequently you're turning in tickets. Those tickets have SLAs, and then in order for those tickets to be executed, they have to go through security reviews. Sometimes the tickets may not be understood, and you got to jump in a war room or jump in a meeting, right? And that back and forth is kind of at the heart of the friction between application and infrastructure teams. And the concept that I really want to talk about here is the fact that application development is, in this instance, tightly coupled to the network. And that's certainly true where IP port, firewall, and subnet configuration needs to happen before development teams can test or promote. And this gets even more complicated as you think about working across hybrid and multi-cloud environments, where, if you're dealing with public cloud to your data centers, it's really an apples to oranges problem of getting everything to work together. And like I said, that then leads to, the interface between application development teams, which is, whatever processes an organization accomplishes. So with that perspective, I'd actually like to hand it to Liam. Liam, can you give the networking team's perspective on this in terms of, I gave, obviously very application-centric view.
Yeah, well, I suppose you also painted a lovely picture there of how application teams are always the modern ones that are moving ahead and driving that business forward, whereas the network teams are holding everybody back. But what we actually see is that there's two sides to the same coin here. Regardless of whether you're trying to modernize your network or modernize your application, there is that coupling of your application and your network together is the friction between them. So any change on either side, any change to your network, any change to your application is going to involve some bit of friction on either side. Now, the limitations on the layer 3 traditional way of doing this from an application modernization, application migration scenario, you've got so many different parts to this. My big thing is that the focus of that migration. When you're in a network or in the networking space, everything, as it says here, everything is IP based. So you've got, how do I make my prefixes available where I need them to be? So I want to now adopt a new platform somewhere. I want to adopt a new site. I want to move my applications into a public cloud. I want to just put them into a different partition on the same cluster. Whatever it might be, I've got constraints around what IP addresses are allowed to move across my network. And I need to somehow make that flow freely, while at the same time ensuring the security of it. So I don't really want to open up all 250 million IP addresses that AWS owns from a public range perspective, but I need to be able to move my applications up there. So I want to tie it down. And if I'm going to tie it down, then it's going to make things very, very difficult for me, especially when you start looking at public cloud environments where you can only, advertise out like 30 unique prefixes out of that environment. So it makes things very, very complex then to try and achieve this. You want to look at what the big picture is going to be, but trying to migrate in bit part to get there is very, very difficult.
Nice. So one thing that we encourage you guys to do, not knowing, the folks that are in the call today, kind of what your background is. Certainly, if you disagree or take issue with kind of my admittedly app-centric view of the world, and Liam's calling me out on that, and also giving the networking perspective, we'd love to hear from you guys. That's exactly why we work on this product together, right? Because it's something we're really passionate about, is thinking about how we could actually help to kind of address this problem or this challenge. So, to make this tangible, I want to talk real quickly about a real world use case, and one that we actually work on here at IBM quite a bit. Obviously in the past year, there've been some significant changes, in terms of like VMware and how companies are thinking about that technology stack. And as we work with customers who have been hit by the VMware, the Broadcom price cliff, customers are a lot of the times viewing this as a forcing function of, certainly we have a cost forcing function, but also we have a lot of stuff running in VMware, and we haven't really sat down and thought about, well, if we had to move it, some of it we want to modernize, some of it we might want to just move somewhere where we can run it cheaper because we're not really going to change it. Some of it, we actually are thinking about retiring at some point. We might replace with third-party applications because we've written a lot of custom products. So as we lean in and talk to customers, we understand the real-world challenges of a migration from a layer 3 networking perspective. Customers' big concerns with migrations, once they figure out, what's my landscape of different things I have running, and then what's kind of my strategy, then they start to think about, well, where am I going to move things? Do I want to move things to something like a Red Hat OpenShift where I could modernize it? Do I want to move stuff and just pick it up and lift it, but I have all the dependencies to that I'd want to move to potentially an OpenShift virtualization environment? So they think about, how long is it going to take me to migrate this stuff? But more importantly, what's the risk? Once I start, lifting, moving stuff, doing a bunch of network configuration, I'm at the risk of, downtime and potentially extended downtime, weekend deployments, and not just disrupting the application itself, but also have to manage all the upstream and downstream dependencies. Because when you're leaving VMware to potentially moving to other kinds of environments, just doing a rehosting is no longer an option. You're really thinking about application level migration, which introduces these ideas of, extended periods, years to migrate things, service disruption. So that's an example of a problem where customers come to us and say, I need to deal with this problem, but I don't have 2 years to migrate this stuff, and I can't afford to have a bunch of critical downtime from applications. So that's where we start to think about, well, at IBM, what is an alternative to how we could help our customers with these kinds of problems? Whether it's migration, where you're worried about long downtimes and disruption, but also at the same time, if you're thinking about modernization, where again, the false equipment, or the kind of the false dilemma of modernization is, I have to leave stuff where it is and potentially rewrite it, which could take forever. Or I have to completely rewrite stuff new in some other environment, or I have to basically do the 1,000 small moves of breaking up a monolith into microservices. It'll take me 5 years, both of which are unappealing options, because the network connectivity between legacy environments and Kubernetes environments, the overhead is so significant that it takes a really long time to build up momentum. So we thought about, how can we start to leverage layer 7 connectivity to benefit our customers who are dealing with these high rate of change, complex architecture use cases. So when we think about the advantages of layer 7 connectivity, we think about first the idea that we're no longer dealing with IP-based routing, but we're really dealing with the ability to treat things as named resources, or use identity-based routing of naming the actual portion of the application itself to connect it. It's effectively the same mindset as thinking about DNS, where we start to think about something as having an identity that is distinct or abstracted from its IP. Next is that we have the ability to start leveraging features and service meshes, and we'll talk about that in a second, where we can actually have traffic management and observability functionality that isn't at the packet level, but it's actually more at the application level, to think about an application holistically and about how we implement observability and load balancing at the application level. Next is, one of the advantages of layer 7 is it is highly agnostic to the types of environments that you connect. So as with unlike with traditional layer 3 networking, which is very much aware because IP and ports and all that represent the specifics of the environments you're connecting. And of course, Kubernetes has different networking characteristics than with like bare metal. Layer 7 connectivity is very agnostic in terms of how it connects. I'm going to let Liam correct me here in a second if he'd like to make anything better what I'm saying. And of course, we support all kinds of application traffic. TCP supports many different protocols. And last but not least is, layer 7 traffic that we use today for HTTPS and all consumer applications is MTLS encrypted. It's the most secure way to send information between disparate environments, sites, and clouds. And by setting up layer 7 connectivity, we're actually really connecting applications in the most secure way possible and really reducing the attack surface of applications as we connect them. Liam, I'm going to actually hand over the benefits to you. And also if there's anything you'd like to fix on what I said about the benefits of layer 7 or expand on.
Yeah, I was just going to mention about how DNS, it's kind of like DNS, like you said, except without the resolution bit. So when most people think about DNS, you think, oh, that's my name. I'm going to resolve that to an IP address. I'm going to use that IP address to get across my network. With application, with layer 7 based scenarios or connectivity, what you have is you already have your name and you know where your name is. You're just connecting name to name. So all of your policies are based on those actual application names. There is no requirement to resolve them to an IP address for routing purposes. So the benefits that you get from this then is the fact that now you're abstracted away from your IP address. So when you have your name and you no longer are dependent on that underlay network, that underlay IP address, now you've got your application layer abstracted completely from your underlay network. Now you can derive what how your application needs to communicate across your environment. It means that any changes that you make to your application, be that to add more endpoints to it, to add more micro segments, to add more microservices, to add more capabilities and resiliency. All of that happens at the application layer and is completely agnostic to what's going on in your underlay network. Also with that, coupled with that is the fact that now that I've abstracted away my critical application connectivity from my underlay network, I can now go ahead and perform under a network modernization, migrations, changes to my underlay network without impacting on that overlay as well. So, it creates a scenario where I can now have what we call locationless applications. If I've got a locationless application, it's no longer tied to that physical infrastructure. It can now exist anywhere I need it to be based on what services it requires, where I need it to be from a geographic perspective, and anything that drives me to having it in a specific location over something else means I don't necessarily need to drive that connectivity down into my underlay network and try and figure out how I work that in a specific scenario at a general level. So at an application level, I can be very, very specific, very, very granular about what parts of my application I need to communicate. And as opposed to at a network level where every change that I make at an underlay network is impacting on everything else.
So hopefully at this point, if anybody has any questions, certainly if you'd like us to dive a little bit deeper into what layer 7 is, if you're not familiar with it, please throw us a question. We're happy to explain more, but we're going to go ahead and step forward a little bit. So it's not going to be a surprise if you're familiar with the networking space and you have some exposure to the concept of service meshes. You're going to understand that there are a variety of service meshes out there that are of the Istio type family that already do layer 7, use layer 7 for connectivity. But this is where I'm going to be a little bit opinionated. And of course, if anybody has issue or would like to, pushback, I'm totally great with that. So, traditional sidecar-based service meshes are incredibly useful and were created for, specific use cases around the difficulty of connecting Kubernetes environments, right? So, service meshes, the Istio Envoy, really created by Google, and also I think IBM contributed to that in its early days. They were created to help with the concept of abstracting connectivity within a cluster and later between clusters, right, for Kubernetes, and have since been expanded to be used for cluster for Kubernetes to VM as well. And they do use layer 7 connectivity. The trick is that sidecars are really complex to implement and maintain. One, because when the architecture changes, you have to typically re-implement the sidecars. They're implemented at the pod level. So when the architecture changes, they need to be redeployed. The other is the sidecars do or can, put both increased resource overhead as well as introduce latency into the system because they introduce additional hops, and as traffic packets are going through the sidecars and are being expected and particularly routed, this can all add to latency. So the combination of build, manage, deploy overhead plus resource overhead plus the potential latency, it means that for a lot of use cases where you're in a more steady state, really focused on operational fine tuning or operational, environment centric activities, sidecars can be very useful and can be worth the extra investment of time. But there are a lot of other use cases where traditional sidecar based meshes are really not appropriate. So in high rate of change, you would never use a service mesh, traditional service mesh for a kind of, VM to Kubernetes migration. And same thing with modernization efforts. If you're modernizing, again, every time you make a change, you have to redeploy. Modernization is about deploying a bunch of changes. So while there are options out there, already people have explored the benefits of layer 7, using it with a sidecar mesh, is a sidecar-based service mesh, is not really appropriate in a lot of use cases. And so there's kind of a gap there. And that's actually one of the things that we want to talk about today. I'm actually going to look, I think we got our first question, Liam. When you mentioned zero trust in this context, is this something similar to an app that should be done with security teams like DevSecOps, if not exactly that team? So when I talk about zero trust, and I'll actually bounce back 2 slides. So, and Gian, I always say, I'm a product manager. I know a good amount, but I also know the limits of what I know. So when I think about, progressive zero trust, we start with the idea first of, we're encrypting traffic, right, between identified instances. So it's encrypted traffic between 2 things that are known to each other what they are. But then we expand that with the use, and Liam's going to show this here in a second, where when we implement policies that are identity-based policies, meaning every part of the layer 7 connectivity we built is a named resource. It's an identity. It's an identity specified resource as opposed to just an IP address. We're actually moving towards what we would consider to be zero trust. Now, obviously, there's other aspects of zero trust, in terms of you validate that all the things are what they say they are, and that you're then doing certificate-based, every handoff is a certificate-based handshake of 2 parties who acknowledge each other, know who they are. But the ability to implement MTLS encryption plus identity-based policies, as opposed to just IP or firewall configuration, is a way to figure out what should pass through, is to us a progressive step towards zero trust. So in our perspective, the technology does some of it, but there's also, and we're going to show here, Liam, in a second, the tool, which needs to implement the policies, which also plays a part in implementing that. Hopefully I clarified. And Liam, is that good, or can I move along?
Yeah, you can.
Okay, cool.
That was very good.
Great. All right, so this is where we're going to do a demo here in a second, but spoiler alert, we're going to talk about an IBM product. So I've talked up to this point about the benefits, the limitations of traditional layer 3. We've talked about the benefits of using layer 7 for a lot of connectivity use cases. We talked about there are, of course, traditional service meshes that do layer 7, but traditional service meshes are not appropriate for all use cases. There are, however, a lot of use cases that fall outside of this idea of steady state. And at IBM, we looked at that with Red Hat, and we've actually taken an alternative approach to a service mesh that is both committed to layer 7, but also is a philosophically different approach to how we think about deploying, building, deploying, and managing connectivity. And that's actually rooted in an open source project called Scupper, which our partners at Red Hat largely sponsored. And then at IBM, we've actually taken that and extended it by building a managed version of the Scupper open source project. And here's the philosophy behind the product. The philosophy is that we want to enable intra-app connectivity in as easy and scalable and secure a way as possible using layer 7 that abstracts away the need to do any underlying configuration of the physical infrastructure. So as Liam and I've said many times, really decoupling application teams from networking teams. From our perspective, what that means is we're actually giving application teams the ability to deploy within guardrails set by infrastructure teams their own virtual application networks using layer 7. Those connections are super secure because of the MTLS encrypted traffic, but they're also very resilient because we're able to leverage the benefits of TCP with like shortest possible path and the ability to build in resilience and load balance and a bunch of other capabilities. And also leveraging a technology which is really agnostic to the environments, clouds, and sites that we're connecting. Layer 7 can move between any environment, cloud, and site. So we wanted to be able to build application connectivity as well. So if an application is running partially in Kubernetes, partially in bare metal, partially in a mainframe, partially in an edge application, the ability to connect it easily across all of those architectures. And last but not least, certainly open source is fantastic and many companies are comfortable with open source. Many other companies, however, especially as we move closer to production, want a robust control plane that not only does security controls like policy and role-based access control, but also has a full set of APIs to support programmatic automation through whatever your flavor of Jenkins, Terraform, Ansible is. And so that's actually what we built, is we took the Scupper open source project, which is our data plane, and we've actually built a control plane on top to create this kind of lightweight connectivity. So it's great to talk about it, but I'd actually rather show it to you. So with that, I'm gonna hand it over to Liam, and he's gonna give a demo focusing on how easy it is to kind of visualize and connect applications using mesh. And then we're gonna come back and we're gonna talk about the applications of layer 7 and a way to think about it. And obviously, as we go through this, if you have any questions, please holler at us and let us know.
Thank you, Jason. I hope you can all see my screen now. So with hybrid cloud mesh, I think I just want to pick up on one thing that Jason was talking about when he was talking about the other service meshes that operate at layer 7. I would kind of categorize it into two areas. So you got your traditional service mesh solutions that exist in the market today, and the majority of them I would classify as infrastructure-based service meshes. These are service meshes that do a really good job of specifying what traffic is allowed in and out of each pod within your cluster. That's their real function here. With hybrid cloud mesh is an application-centric service mesh. So everything related to hybrid cloud mesh is about the application. It is specifically about how an application needs to talk to each other. So it's not just, it's all about putting the application in the center of everything you do. This is our, and this is hybrid cloud mesh. So this is our SaaS manager, the centralized control plane. The data plane exists in the customer environment. This is our SaaS control plane. I've got an application inside here that's got its own van. It's called Code of the Day. I can see here where my partitions are and what applications I have. So I've got my front end that exists over here in US East, and I've also got an OCP version of it, OCP deployment in London, where my back end exists, and this is my application here, and I can generate quotes from this. I can generate quotes from that because I've put a policy in place that is advertising one of my services. My quote service here is now being advertised locally into my front end environment. And I can look at that through my policy connections here, and I can show you that I've got a policy that says quote is linked to this namespace here. That means that this gateway, pull up my legend here to show you what they all are. So I've got an edge gateway in my front end environment, and it is connected into the namespace of that front end environment. Its job is basically, I've put this policy in place to identify this application service. This gateway is inserting that remote service into this local namespace, and it is saying that it is that service. So when my front end web application needs to talk to quote, every time I click that button, it needs to talk to quote and try and figure out how to get there. My gateway is just going to hold up his hand. It acts as a service proxy and says, that's me, I've got that. And then means that I can then look at that. It goes a lot easier if I just pull out that. And then I can actually drill down into that quote connection. And I can see the traffic that I've got going on there. Now, you're actually seeing a lot of legacy stuff there as well. So what I'm going to do is I'm going to pull this up and see, this is my application registry. So I've got all of my applications here. You can see I've got a single deployment of all of these. What I'm going to do now is I'm going to go into my gateways. These are the virtual routers that I've got deployed in my US East and London deployment. And I'm going to add in a new backend environment here. I'm going to deploy this gateway into my Dallas location. So I've got a backend cluster that I've already deployed. I'm going to specify that this is going into this application group. And I'm going to deploy this. So when I go and deploy that gateway now it's going to be deploying there. Once that deploys into that namespace of that new location, I'll see that it's already done it. It's gone and discovered all of these backend services already. So when I go into my topology view and look at this, I can now see that I've got a new location on here, US South. So I've deployed a gateway into US South. And when I look at my services, let's turn off the application connections and just see the services. So I can see this whole new backend here, which is a complete replica of what I already have in place. So I've got my gateways, and all of my backend has been automatically discovered by deploying this gateway into place. So now I can go into my front end, and I'll show you exactly how we do that type of application connectivity. So I'm going to create a new connection. I can specify inbound or outbound depending on whether my remote gateway is sitting behind a firewall or not. I'm going to start off by giving this a metric at 30, which means that I'm going to load balance across these, because you can see here, so the lower the cost, the lower the link metric, the more preferable the connection is going to be. Now that I've got this connection in place, and if I look at my apps and services, I got my connections are in place. I can see I still got my connectivity, but actually now that I've got connectivity in place, so I'm just going to show you my policy for that. This one here to allow quote. This is allowing that quote service that I had inside my apps and services. It's this guy here. So now I've got two of these. But what I actually want to do is show you this. So if I don't have this policy, I am not I'm just going to delete that policy. So now I don't have it. So I already had, so network is still there, but because my infrastructure is still in place, I still have my gateways. I still have my connections between my gateways. So if I look at this, I still have my gateways and my connections between those gateways. But now if I go to my application, I can't get it because I don't have that policy in place. So I've broken that. So I'm going to add that. I'm going to add policies back in and restore service to my application. So this is how easy it is to add that kind of connectivity. So I'm going to select my front end. I can either do this policy for the entire network segment, so for the entire virtual application network for quote of the day van, which is all 3 deployment environments there, or I can specify a single namespace to expose that into. So I can be very granular about where my service is allowed to be reached from. So I'm going to specify my front end where it's allowed to go. That is the source. So my front end can look for this service. And I'm going to select it, the service, and I'm going to create that. And now I should be able to see my policies in place. So if I go to my partition view, if I turn on policy connections here, I'll see I've got 2 policies in place, one to either back end. So one policy, because it's the same, because I've got 2 deployments of this quote, I've only had to add 1 line of configuration. One policy goes into place, and that has allowed both of these services, quote of the day quote, to be advertised into the front end. So that means that I should be able to, yep. So my application is back working again. It's great news. Furthermore, I can start adding policies for the other parts of my application too to make the rest of these buttons work. Because you'll notice that I've also got, I could order engraving, but if I look for my, nope, can't get to the order. So let's go back to my home page and I'll just make these other buttons start to work. So I'll allow that author. And again, I will specify that from my front end to author. And now when I go back to it, I can now get to my author and see who it is. And I can turn on rating and see if it's a good quote. Specify my front end. I'll turn on rating. And I'll generate a random quote. And now I get in ratings as well. Now, that's all well and good. But what do we get for all our trouble? So now we've got a front end, we've got 2 back end environments. I've got some policy connections in place. But what would happen now if I was to say lose one of these environments? So I added in the new one in Dallas. So let's just go ahead and take out this London one that was in place. So all of my connections were going to here. So with that gone, it always takes a minute. With those gone, my environment takes over. Hybrid Cloud Mesh manages that connection for me. And manages the connections for me and keeps the service flowing, even with those load balance scenarios. So it takes over all of that for me and makes it not real simple for me to put that kind of connectivity in place. And that'll also allows me to then create more complex kind of DR type scenarios. So I can add it back in at a higher metric for my on-prem environment, adding that connection back into place. Connections. Oh, here we go. So adding that connection back into place, allowing me to have a primary and a DR type scenario. And on top of that, once I do establish that connection back across, I can turn on and see my application view and see how well connected this is. So I can see my web, and let's select one of these here for rating. And I can see my bytes in and out, my average latency across that environment, and then be able to tolerate those kind of network fluctuations underneath now that my application is abstracted from my underlay network.
Awesome. Thanks, Liam. Yeah, no, that's good. Yeah. So perfect. So I know everybody's shy, so I'll go ahead and answer the questions you're all probably asking yourself, which is first, that what we were just showing you, like I said before, it's a UI, but all of that can be done through programmatic APIs. So everything that Liam was showing you can be deployed through whatever your automation tools of choice are. And the second is, well, who would be doing that? Would an application person be doing that? DevOps, networking? And the answer is yes, because anybody could use that product to establish that kind of connectivity. Our proposal, which I'm going to talk about here in a second, is this actually gives networking and application teams a different way that they could work together, which I'll talk about here in just a second. So before I get there, before I talked about the traditional sidecars not being the right tool for the job for these high rate of change application-centric activities, and Liam was showing you there how easy it is to establish connectivity using hybrid cloud mesh. I mean, you can literally establish connectivity between different parts of an application across different environments, sites, and clouds in literally just a matter of a minute, implement policies, implement load balancing and DR, and you do it all without ever having to touch the underlying physical network. So when you think about a monolith being broken into a distributed monolith into microservices, the volume of changes that application teams make, but also the usefulness for application teams, if as they're making all these changes, they can think through their own load balancing, their own DR recoverability, so they're not breaking things, they're not causing downtime as they're actually rewriting and redeploying. They could leverage this product without having to turn in tickets, meetings, and war rooms to keep things connected. We got a question real quick. How does this product actually become aware of the networks we have in our environment? How would it become aware of our VLANs for on-prem or VNets in the cloud? Okay, I have my product app answer for that, but I'm going to actually let Liam answer. How does the product become aware of the networks we have in our environment?
Our product is meant to be completely agnostic of those networks that you have in your environment. The data plane will utilize the underlying network that you have within your environment. The idea is that your application needs to only be aware of its services and not have any influence on what's happening on your underlying network. You want to keep those two things separately. As soon as you integrate your underlying network with your application, now they are both in the same stream. So that means any interruption of your underlying network is going to impact on your application. So we aim to keep those two things decoupled at all times.
And one thing about that, great question. If you are interested more on how the Scupper data plane works, I'm including the link here at the end to both the Scupper product page as well as the GitHub repository. And you can certainly learn more about the concept of the routers that we're using and how Layer 7 works on top of that. Because it is a new way to think about things of building connectivity between applications without in any way, shape, or form coupling to the underlying physical network. So I want to kind of end the talk by talking about 3 adoption models that I'm going to propose. Again, I come from an application background, Liam comes from a networking background, but I want you to think about this in terms of how this can change how a company develops applications or executes on the company initiatives through partnership between development networking teams. First and foremost, and we've already talked about this, when you have critical modernization and migration initiatives, where if you could bypass the need for network configuration and allow developers to self-serve their networking needs, and we already showed you the policies and the resource controls can be used by networking teams to set up walled gardens for development teams and say, hey, here's a set of resources, but with these resources, you can do Layer 7 connectivity however you want. That bypasses the need for network configuration, and for these critical initiatives allows you to accelerate time to value, lower cost to value, because it requires far less people hours in order to accomplish this. And you can do it with no downtime, because with Layer 7, it's very easy to set up connectivity and then just route traffic, because the connectivity can be set up, for a blue and green deployment or canary deployments. There's a bunch of ways to do this. And the other great news about this is for these temporal use cases, you could use a product like Hybrid Cloud Mesh and actually scale up and then scale down your licenses. But we actually believe there's a lot of applicability for this beyond just day one use cases. 2 of those would be, first, leveraging the power of a product like Hybrid Cloud Mesh and Layer 7 connectivity in all of your pre-production environments. What if development teams in dev, test, and UAT could actually manage all their own connectivity without ever having to go to the networking team? Now, once you go to production, of course, we think and know that Hybrid Cloud Mesh is completely appropriate for production use cases as well. But at this point, you might want to leverage partial Layer 3 or bring in security ops. You might even want to revert completely to traditional Layer 3 for whatever reasons. But we actually believe you could develop your applications in non-production environments much, much faster, right? Where infrastructure sets the guardrails, DevOps owns all the connectivity. And then, we can talk about what the appropriate thing to do in production, because obviously going to production has a different level of oversight and, compliance that it may be required. And last but not least is, in production environments, if you're connecting applications that have to sit across hybrid or complex architectures where the networking is difficult and where your rate of change is high, or the risk of outages and the difficulty of implementing DR and load balancing is high, Hybrid Cloud Mesh is a fantastic approach to leverage for decoupling your apps from your network and connecting applications across heterogeneous topologies and architectures. These are 3 of the kind of seeds that we would want to plant with folks, that the temporal use cases are great, but there are also these day 2 kind of continuous use cases that represent a change in how application and networking teams work together. And the other thing we want to say is the great news of Hybrid Cloud Mesh, you can adopt and test it in a very limited, POC, and then think about how you expand it in your own organization. Certainly as Liam and I have gone out and evangelized this with customers, customers have given us their own feedback about, well, actually, we kind of think we might use it in this use case. That's exactly what we want to generate. We want to show people that it's possible for application teams to self-serve with their own connectivity without introducing risk of security breaches or performance or resilience issues. But we're also giving infrastructure and networking teams the ability to maintain control through a robust control plane. And by stimulating that, we're actually excited to hear from our customers where they might see this as being applicable. So how can you learn more about hybrid cloud mesh? We would highly encourage you. This PDF, my bad. I think I posted the deck for this kind of late, so it'll be up in the TechCon website. But you also see my email address there. If you're anxious to get your hands on this deck, you can just email me. I promise I'm not going to barrage you back. If you just want to reach out and say, hey, I'd love to get the deck, you can reach out to myself or Liam. But I'll include the links there to the hybrid cloud mesh product page. And we encourage you that if you're interested, we certainly have ways through the website, but also by reaching out to Liam and myself, we'd be happy to point you to ways to get a deeper demo, get your own sandbox environment. We actually can provide a sandbox where we have already set up environments and you could use the hybrid cloud mesh product. But also if you reach out to us, we could also potentially explore a free trial. And at the same time, we are based on Scupper open source project. You can always go there to their homepage and their GitHub project. And we'd encourage you as well to download Scupper and play around with it to understand the power of the data plane. Bearing in mind, of course, that a lot of the functionality we showed you here today is part of our managed SaaS control plane. So with that, that's kind of what I wanted to communicate from my side. Certainly, we've got time for additional questions if anybody has one. And Liam, I'll leave you the last words if you have any parting thoughts.
No, I'd like to get everybody's thoughts. So let's move on to some questions. Dan, if there's any questions there for us.
Well, those were the extent of the questions that we had.
Okay, excellent.
I'm going to answer questions as I go kind of guy. So yeah. Sorry about that. Sorry, not sorry. We'll give everybody a minute or two and we'll sit in awkward silence. And if there's no questions, we really appreciate everyone attending. Please, we encourage you to reach out and learn more about this powerful technology. And as always, Liam and I are product managers, so we're very friendly. We don't bite the way that salespeople do. So you can reach out to us and we're happy to nerd out about this.
Yeah, so I'll fill the awkward silence a bit with my my two superpowers of hybrid cloud mesh. It does two things brilliantly well. Locationless applications. So by abstracting away your application connectivity from your underlay network, you're not now tying that application is no longer tied to an IP address. It's no longer tied to a particular piece of infrastructure, and instead gives it a locationless capability. So it can now exist anywhere you need it to be, and hybrid cloud mesh can deliver the connectivity for that. It also, the second thing that it does brilliantly well is secure application connectivity over any network, over difficult to route paths. So any environment where you've got applications, and I've come across some of the most complex networks that I've ever seen were all on-prem, zero public clouds involved. But when you start including public clouds, a single, multiple, and we're starting to see lots of that now. There's many customers that we're talking to have strategies of multiple public cloud environments. The complexity of their network and their connectivity needs are growing exponentially. So this is the kind of solution where you can mitigate much of that complex connectivity requirements by very much simplifying through being more specific or more granular at the application level, which gives you more power.
Yeah, and this almost seems like magic. I mean, it's almost making it look like old layer 3, type of connectivity, like old school. Would you say that's the case?
Yeah, like I sometimes look at hybrid cloud mesh and start to think of the relationship between hybrid cloud mesh and what we advertise across it and how we do it to kind of more traditional layer 3 environments, where in a layer 3 environment you've got your IP addresses that you advertise using routing protocols from one location to another, and how they're learned from different locations, and what's a preferred location, etc. Hybrid Cloud Mesh does very similar things, but it's the service names. So you get service.local suddenly becomes a remote capability to you. Your application thinks that everything it requires is all local to it. So it sees everything as being local to it, makes my application coding a lot easier to do, but also means that I've now abstracted that away from my network. So what I'm advertising across are those service names, and I use AMPQ as my routing protocol, let's call it that, to advertise those service names across my network. So my routers have their service registry, which is effectively like your routing table. So it's like my IP table, and I can perform my connectivity across that without ever needing to resolve a service name. I'm advertising the service name across that environment.
So what would you say to like some network guys, right? They love getting into the tables and the and I mean, what about them that are kind of hesitant? They kind of hold the keys to some of this network, doesn't want anyone to change what they're doing, to mess up, this great, monolith of stuff they have going on. I mean, what would you say to them to say, hey, this is a good thing for them?
Oh, this is a great thing for them, because I know that Jason was talking about it from an application point of view. So the application teams trying to figure out how they can move faster, but with network teams are always trying to innovate. Network teams are some of the most clever folks that exist in an enterprise environment, and they're always trying to figure out. They're always, number one, they're always stuck with budget, so they understand the cost of everything that they do. They understand how it impacts on the bottom line for every one of their apps and services, because if the network goes wrong, nothing functions, and they always get a kick for that. But when it comes to hybrid cloud mesh, if you can abstract away your application connectivity needs from your underlying network, now your infrastructure team can now go ahead and install those next-gen firewalls. They can now go ahead and make those critical network changes that's going to make their life easier, increase their visibility, increase their security, or perform those changes without impacting the critical applications that reside on top. So
Liam, actually, we got a question from JW, which are, what are the requirements for the underlying network to facilitate this product working? Firewall rules, routes, etc. Ooh, let me answer. And Liam will tell me if I got it wrong. There's two things. Number one is we need to have port 4443 open, right? That's what allows TCP traffic. And the second is, and Liam showed this, but he didn't talk about it, we really need to think about client to service or outbound in routes where we're going from, what is it? Not trust. Public. Private to public, right? So we within our you can configure the routes to allow stuff to enter through the firewall, and if you configure it to go in the other direction, then you would need to potentially modify your firewall rules for the application in question. Did I get that right, Liam? I'm always learning.
Yeah. Pretty much. Port 443 is for MTLS. It's also HTTPS. So every secure website on the internet uses port 443. The majority of internet firewalls will all allow port 443 outbound. So that allows you to create that HTTPS connection outbound. So the way that we create the connections, the MTLS connections between those virtual routers, we can specify the direction that you want to initiate that MTLS connection. It's a bidirectional tunnel, but you initiate it from the trust side to the untrust side, thereby meaning that you don't actually need to open a firewall port to allow that to happen. But what does need to be in place, those routers do need to be able to reach each other to build an MTLS tunnel to each other. But you can also create more complex routes. So if you have an environment where you've got airlocked type networks where you've got sections of your network that are publicly accessible that can never talk into those environments. Maybe you can, you can now create virtual gateways that can be reached from each other and create scenarios where as you can create these complex paths that were allowing an application talk to a service in a location that it was very, very difficult to route to, but I could add in a number of gateways that we can hop that traffic through and only allow that named application or named service at the end communicate to a named service in that secure area. I don't need to allow the IP addresses end to end. I just need to have a policy to expose that, and now I can hop that application traffic without actually needing end-to-end connectivity to deliver that service.
Okay, great, Liam. Hey, listen, we're at the top of the hour. I'm so glad for the interaction that came in. We're out of time right now, but if you'd like to join us at the office hours right after the next session, we can continue our conversation. We just continue with asking more questions. By now, most of you know the drill. There's a survey. Please provide your feedback on this session. And if you haven't already, please join the IBM Tech Exchange community. And of course, don't forget to select your next course section. And hopefully we'll be able to see you soon. Take care. Thank you.
Bye-bye.